We are starting to work on our sevens here. What did we do on last chapter? Yeah, we hadn't worked on our sevens in the last chapter. So chapter 14 is when we're just starting to get into our sevens. And of course, there's always review from the chapters before. But the sevens, when it comes to the sevens, those are the ones that we really just have to memorize. So it's good to write those out, even if you just write out your answers, like 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, and you just keep writing them like that until you get all of them, at least these memorized, because when you do that, then it becomes really easy for you to later go on and kind of know what your numbers are, what your answers are for the sevens. Okay, so at least do that, but I would prefer you to just do the 7 times 1 equals 7, 7 times 2 equals 14. I would prefer it out because that really does something to help your mental math, just your mind remember it that way. Okay. So so that's what we start with. We start with the sevens. 7 times 6, that's 42. Okay. There's a lot of review here. The nines, we always do them the same way. Okay. 6 times 9, what do? What number are we multiplying by 9? The 6. 1 less than that is 5. 5 plus 4 equals 9. Okay. We always do it that way, because that way we just don't have to use our fingers or any other kind of, this is a faster way. If you can do this, then you are golden with the nines. Okay, then we have reviews of the rest of our digits. We have 8 times 6, which is just another one of, we've already done our sixes before, but if you don't know 6 times 8, right? If you don't know that, then what can we always do? We can do 8 times 5, which is 1 before it. So we do 8 times 5, we know that that's 40, because it's just half of this number with a 0. If it's an even number, and if it's an odd number, it's half of that number, but ending in a 5. So this one's even, so it ends in a 0, and half of 8 is 4. Okay, so we know that's 40. And if we're just adding one more group, right, because this is 6 groups of 8 and this is 5 groups of 8. So if we're adding one more group of 8, that's just an 8. So we know that 6 times 8 is 8. 48, sorry. So yeah, the 8s are kind of nice because we can go back to our 6s, or anytime that we're doing anything times 6, we can always go back to the 5s and just add one more group. But the 7s really kind of are in the middle where we can't do much about it. So that's just the 7s and some review. Okay, when we go over here, it shows us, it says 6 counted 8 times, and we went over this before. This is just review. Anything that says counted just means 6 times 8. Counted 8 times means they had 8 groups of 6, so they counted 6 8 times. So that's just multiplication. Same thing for 18. Over here it says color all the boxes that have a number you would say would skip counting. So that's what you do. You just count by 6s and you color the 6s. So it would be 6, then it would be 12, then it would be 18, and so forth. Number 20 says ants have 6 legs each. 7 ants are working in a tunnel. How many legs are working? Okay, so that would just be the 6 times 7, which is 42. Okay. Okay, then we move on to 14b, and that's some more review and some more. There's 6 times 7. I see that again. And I don't think that we're actually doing the 7s here. These are 6s, but we're they're only putting the 6 times 7, so we're not quite into the 7s, just the 6s. So, and the 6s are pretty easy, like I said, because if you don't know them, you can always go to your 5s, and 5s are easy. So, for example, we have 6 times 6. If we just do 6 times 5, we know that's 30. And since this ends in a 0, it's easy to just add 6 to it and know that it's 36. So this equals 36. So if you just do that with all of your numbers, you can easily, if you're still having trouble with your 6s, you can easily find it that way. Okay, over here there's some more, just fill in the blanks, and remember how this works. It's 6 times 0, then 6 times 1, 6 times 2, times 3, times 4, times 5. So it keeps doing 6 times and going all the way to down to this 6 times 10, but you're always multiplying the next number. And at the top is your answer. So 6 times 0 is 0. Okay? And then over here would be 6 times 8, because that would be 48. 6 times 2, this is going to be 12. And so forth. And again, over here it says 6 counted 9 times equals, so that's just 6 times 9. 6 counted 9 times, counted just means multiply. Number 19 says 6 insects landed on my window. I could see all of their feet. If insects have 6 legs apiece, how many insect feet did I see on my window? So that's 6 insects. They each have 6 legs. So 6 times 6, that's 36. Okay. Number 20 says, the 6 houses on our road each have 6 apartments. How many apartments are on our road? Okay, so that's the same thing. 6 houses, 6 apartments. You multiply those. 6 times 6 equals 36. Okay. Over here, there's some more practice and review. Okay, over here, we're going to do this. This is our perimeter and area. And I just thought the other day that I have a better way of teaching this. I just thought about it. And what I want kids to do is I want the students to start writing out the formula that they use to solve this problem instead of just trying to figure it out in their head. Because if we write out the word perimeter, okay, and we write out the word area, okay, then we know that one of them is just multiplying 2 sides, right? The length and the width, that's the area. Length times width. But the perimeter is when you are adding every single side. So it's length plus length, because there's 2 lengths, and then plus width plus width. Okay, so those are our 2 formulas. So what I want students to start thinking about is perimeter is the longer word, and it goes with the longer formula. Area is the shorter word, and it goes with the shorter formula. Okay, and so if we can start thinking that way, then I think that will help, because a lot of the students are getting these 2 confused, area and perimeter. Okay, so if we start thinking, okay, this is the long one where you have to add all of them, and then this one's the short one where you just multiply 2 sides, then that will help a lot. So over here, what do we do? Number 13, we have perimeter. That's what it's asking us for. Perimeter is the long formula, so it's 14 plus 14 plus 2 and plus 2. And I always like, when I'm adding, I always like to add my numbers 2 digits at a time. So this is 20, this is 8. So 28, and then 2 plus 2 is 4. And then if I add these 2, that becomes 32. So the perimeter is 32. Okay, and that's how I do it, because when you just start to add everything all in a row, like one after the other, then it can get confusing and you might miscount. So it's good to do 2 at a time. 2 at a time is perfect. Okay, then we come over here. Okay, over here it's kind of telling us, you know, to make kind of the fractions, right? These are the equivalent fractions to the shaded and unshaded blocks. So over here it has one shaded block, so that's the one at the top, because one is shaded out of 6 pieces. So since all of these are 6 pieces, that's the bottom number, and there's only one of them shaded, that's the top number. Okay, so this one, every time that it's doing it, it seems to be on the top, it seems to be adding another shaded area. So this is 1, and then now here there's 2, okay, over here there's 3, and these become really easy if you start to see the pattern, because 1, 2, 3, oh, that looks like it might be 4, it sure is. That looks like 5, okay? And then the same thing at the bottom, we start to see a pattern. We know that this is 6, okay? These same 6 were cut in half and doubled, so now there's 12. Okay, now they were tripled, so now there's 6, there's 12, and there's 18. Okay, so it looks like they're going by 6s. So if you see the pattern, it starts to become easy because you don't even have to count or look at them. You kind of just can go with the pattern. Okay, Lois, we're going to do number 17 now. It says Lois drank 6 glasses of water every day last week, 7 days. So as we're going further into the book, they're not going to keep reminding you that there's 7 days in a week. That's something we just have to know. And if you forget how many days there are in a week, you can just count your days. You can just do Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And then you're like, oh, there's 7 of them. Okay, so I've seen a lot of students skip those problems whenever it has anything to do with a week. Anytime you see the word week, you're like, okay, they're talking about 7 days. Okay, and if you don't know that, then remember, you can just count out the days on your fingers to make sure you know it. Okay, 7. Okay, so 6 glasses of water every day. So she was going to drink 6 glasses of water every day last week. So in a week there's 7 days. So we multiply by 7. So it says, how many glasses of water did she drink in all? She drank 42 glasses of water. That's how many. Okay. So that's how you do that one. Now this is another one that students have, similar ones that students have been having a hard time with. And what I like to do here is, let me see if I have a pencil. Okay, here's a pencil. Okay, so what I like to do is I would just go here and I would say, okay, Devin has 5 dimes. Okay, how much is a dime? 1 dime is 10. Okay, then, and 3 nickels. How much is a nickel? That's 5 cents. And 8 pennies. That's 1. How much money does he have? So what I would do is I would do 5 times 10. That gives me 50. Plus, that's how much I have for, right, my dimes. 5 dimes is 50 cents. Now I'm going to add these nickels. How much are the nickels? 3 times 5 is 15. Okay, and then my last one is 8 pennies. 8 times 1 is 8. Now I can combine. Okay, and this is 65 plus 8 equals 73. So he has 73 cents. See? And that's how you do that one. So I always like to put my numbers. So if there's dimes, I like to put the 10 up there. For the nickels, I put the 5. And for the pennies, I put a 1. And I'll do that even with my quarts and stuff like that, just to make sure that I know. For the quarts, I'll actually write it out and put 1, 4 quarts equal a gallon and things like that. But for this one, I like to put these because then it gives me a visual and I know I have my 5 there, my 10 there, 3 and 5, 8 and 1. Okay, and it helps me solve it easier. Okay, the next one, it's number 19, says there were 50 apples hanging on a tree. Okay, if 23 of them were rotten, how many good apples were there on the tree? Okay, so this is, there's 50 apples on the tree. 23 of them were rotten. So when 23 of them were rotten, what do we do with those? Do we eat them? No. Do we make apple pie with them? Absolutely not. We throw them away. So that means minus. When you throw something away, you have less of it. So you're subtracting it from your total. Okay? So we're going to subtract that. And then it says how many good apples were on the tree. So if these were the bad apples, probably when we get rid of these, we're only going to be left with good apples. Okay, so we can go ahead and solve, and we can do this. We can do, we can't take 3 from 0, okay? So we have to go to the 5 and borrow, and that becomes a 4, and this becomes a 10. 10 minus 3 is 7, 4 minus 2 is 2, so it's 27. Okay, so that's how many are good apples. Okay, next one says, on the way to the mountain, 4 people rode in the car. Okay, on the way to the mountain, 4 people rode in the car and 8 people rode on the van. Okay, so they're going to the mountain. If there's 4 people in the car, okay, 4 people in the car, and there's 8 in the van. So let's see how many we have all together. We have 12. 12 people all together, okay? On the way home, 6 people rode in the car. How many were left to ride in the van? So this we can just do, okay, well, there was 12 people all together, and then 6 went to ride in the car. Yeah. So then what do we have left? 6 went to ride in the van. So this many, 6, rode in the van. Okay, and see, at the beginning they separated all the people, and they did at the end too, but at the beginning all you have to know with this problem is, okay, we need to know how many people there are in total. Because if we don't know the total, then we can't subtract how many rode in the car from the total to figure out how many rode in the van. But now we have our total because we did 4 plus 8. Okay, because that was at the beginning. There were 4 people who rode in the car and 8 rode in the van. So that means altogether there's 4 plus 8 people. And we got our 12. And that helped us figure out the rest of it. Okay. Okay. Let's see what we've got here. 14E. It's some more 6 multiplication tables. I do see a 7 in there, 7 times 5, but those are our 5s that we've already done. So just more review, and we're working on our 6s. There's more perimeter work over here. And remember, perimeter is the one that we just count all of the sides, all of them. You don't pick 1 or 2, all of them get added. So if we do number 14, okay, it has 3 feet plus 5 feet plus 6 feet. Okay, if we do 2 at a time, this is 8. 8 plus 6 equals 14. Okay, so this is 14. Perimeter is 14. So anytime we're doing perimeter, we just add them all, every single side. Okay, and this is some more of what we did before. There's 3 shaded out of 5. 3 are shaded. 1, 2, 3, 4, 5. There's 5 in all. And it keeps going. The top part is the shaded part. The bottom part is every single one, whether they're shaded or not. Okay. Number 17, Wayne made a pegboard. He hammered 8 rows of nails with 6 nails in each row. How many nails did he use? Okay, so there were 8 rows of nails. Okay, 8 rows of nails. And in each row, there were 6. So we just multiply. And that's 48. Okay. Now when we do this one, things like number 18, these get students confused. Don't let them get you confused, okay? It says Erin made cards. She made 4 gift cards, 16 birthday cards, and 7 Valentine's Day cards, and 19 congratulations cards, and 6 get well cards. How many cards did she make? So that's one of those where they just want you to go ahead and add up a bunch of numbers. And this is the way I like to do it. I like to put it like this. You can stack them, or you can put them next to each other. I like to put them next to each other right now just because of my board. Makes it easier to show you guys that way. So we have 4 gift cards, 16 birthday cards, 7 Valentine's Day cards, 19 congratulation cards, and 6 get well cards. Erin has a lot of friends and family. Okay, so 14 plus 16 is 20. Okay, plus, and then I'll do these as well. 7 plus 19 is 26, and then we'll just bring down the 6. Okay, then we'll do 20 plus 26. That's 46. and then plus 6, we'll bring down to 6, and that is 52. Okay, so then our answer is 52 cards. And this one says 42, but this is not my book. This is not something I did. This is just on a student's book that I kept. So if you see an answer here that's incorrect, I didn't do it. Okay, so that's a good one to practice, because those addition and subtraction skills can always be stronger. Okay, number 19 says a room is 10 yards long. How many feet long is that room? Okay, so if it's 10 yards long, and we want to find out how many feet it is, if we're going to go from yards to feet, okay, what do we have to do? Well, we know yards are bigger. Okay, so remember, when we are measuring something, let me get a visual here really quick. So when we are measuring something, and I'm going to measure this, my little board with the dots, right? I'm going to use some of these dots. They are for bingo games. And if you measure this right here, let's see, we're going to measure how tall, how long the width is of this board with the dots. We do 1, 2, 3, 4, 5, 6, 7. Oh, let's turn it down. It's kind of low. Okay, how many did I count so far? 7, 8, 9. Okay, we'll do 9. Okay, because I can't fit anymore. So we'll say about 9. About 9 dots is how the width of this, right? So we'll say 9 dots. Okay, and so the dots are little. Okay, and I need 9 of them. Okay, now I'm going to take my sticky pad. Okay, let's look at the difference from the sticky pad and the dots. Okay, so here's the sticky pad, here's the dots. See how much bigger this one is? So when we're measuring with a bigger item, we're probably going to need less of them to measure things, right? So we needed 9 dots, and then if I do this, 1, and I hold my spot, and I do 2, okay? So it's a little bit under, so it's about 2. We'll say about 2 of these, okay? Even though there was more space. We'll say about 2 because we can't fit anymore. So for the dots, we needed 9, and for the pad, we only needed 2. We only needed 2 for the pad. Okay? So whenever they're smaller measurements, we need more of them. And whenever they're bigger measurements, we need less of them. So with that same thought in mind, whenever they're talking about, right, whenever you hear anyone talking about a football game, they say, oh, this many yards, they went that many yards on the football field, right? So that's a lot. They're running really fast. Yards are a lot, okay? So those are the bigger measurement. When you think, oh, a foot, you don't think that much, because there's that candy called Fruit by the Foot, okay? So it's just a foot long of a candy. So if they can just roll a foot together and it's in a little tiny pack, then you know that that's the smaller measurement. Think of Fruit by the Foot, and then think about, you know, a football field where they're running in yards, okay? So if this one's going to be the bigger one and this one's going to be the smaller one, then we are going to have more of these, because these are the smaller ones and it takes more of them to measure something, okay? So I want you guys to really think that way so that you don't get confused. So when we do this problem, it says a room is 3 yards long. How many feet is a room? First, we have to know how much is 1 yard. 1 yard is equal to how many feet? 3 feet. So in order to turn these yards into feet, we have to multiply by 3. So we do 10 times 3 equals, and that gives us 30. So 10 yards is equal to 30 feet. Okay? So that was a long explanation, but I really want you guys to start thinking that way, because it just makes it easier to understand. Okay, we'll move on to number 20. The room in number 19, oh, that's the room we just figured out. We figured out was 30 feet long. 30 feet long. Okay, so we'll keep that there because we probably need that information for now. Okay, so the room in number 19 is a rectangle that is 21 feet wide. Okay, it's a rectangle that's 21 feet wide. What is the perimeter of the room? Okay, so they gave us how long it is. This is the length, okay, 30. And that is the width. They just gave us how wide it is and how long it is. So that's our length and our width. And it's asking us what our perimeter is. But first we have to figure out all of our sides, because remember, in perimeter we have to know all of our sides. So if this is 30, this is 30. If this is 21, this is 21. Okay, so now that we have all our sides, we can add them. 30 plus 30 is 60. And then 21 plus 21 is 42. So this equals 102. Okay, so that's our perimeter for the room. Okay. Okay. Here is some more multiplication facts and some more of the same perimeter and the same fractions here. And then we'll do number 17. Number 17 says a recipe calls for 5 tablespoons of honey. How many teaspoons are needed? So we have our 5 tablespoons, okay? And then we have to turn them into teaspoons, and that's going to be by multiplication. How many teaspoons are in 1 tablespoon? The answer is 3. 3 teaspoons, okay, equal 1 tablespoon. Okay, so we are going to have to multiply by 3 to convert these tablespoons into teaspoons. And that gives us 15. So our answer is 15 teaspoons are needed. Okay, that's number 17. And then number 18 says, how many nickels would Jenna need to pay for a candy bar that costs 20 cents? Okay, this is where we do what I said. How much is 1 nickel? It's 5 cents. So we know that we have 5 cents, okay, for 1 nickel, and we have to find out how many nickels she needs to get to 20 cents, because that's what she needs to buy her candy bar. So 5 times what gives us 20? 5, if we know our multiplication tables and the 5s, we should know by now. If not, then practice them. 5 times 4 equals 20. So she needs 4 nickels. Okay, that's how many she needs. Number 19 says 3 dogs and 7 children walked through the fresh snow. How many feet were making tracks? Okay, so we have 3 dogs, and I'll do the same thing here that I do with my money. So 3 dogs. Okay, so how many, okay, how many feet does 1 dog have? It has 4 paws. And 7 children, how many feet do children have? 2. So then now we have our 2 multiplication problems that are going to give us how many feet the dogs were using to make tracks, and how many feet the children were making to make tracks. And then we'll add all of that together to see how many of both of them all together were making tracks. Okay, so first we'll do 3 dogs times 4 paws each. That is 12 paws that are making those tracks. Okay, 12 paws. Okay, then we're going to do the children, and there were 7 children, and they each have 2 feet, so they were making 14 tracks. Okay, they had 14 altogether, 14 feet. Now we can add these. Okay, and 2 plus 4 is 6, and 1 plus 1 is 2, so there were 26 feet making tracks. Okay, so that's our answer for that. Okay, and we'll do the last one, which is 20. Cameron cut a piece of wrapping paper that measures 3 feet wide, so 3 feet wide right there, and 6 feet long. Okay, so 6 feet long right there. What is the area of the paper? Okay, what is area? Remember, area, if we spell it out, is the small word. So it's going to have the small equation, which is 6 times 3. Okay, just multiply the length times the width. 18 is our answer. Okay. Okay, and that's all for this chapter.